Hi, future doctors. Welcome to the next class. In this class, we'll discuss about angular momentum and torque. So, what is angular momentum and what is going to be torque? So, angular momentum in rectilinear motion or straight line motion. So, we came to know momentum. What is momentum definition? Product of mass and velocity. So angular momentum is nothing but moment of momentum. That is nothing but r bar cross p bar. So what is p bar means here? Momentum. R bar is distance from where we are going to apply that momentum. So this one we will call moment of momentum. So in physics, gradient we will use velocity gradient. Change in velocity with respect to distance. Temperature gradient, change in temperature with respect to distance. Potential gradient, change in potential with respect to distance. Energy gradient, already we discussed this, F equal to minus du by. So with respect to distance, what is changing, that is that gradient we will call. Same like that. So with the distance what we are multiplying, that is called moment. Moment of momentum we will call. Here moment means we are multiplying with distance. Now how they will define torque? So moment of force. Moment of force. This one only they will write tau bar is equal to r bar cross f bar. So generally whenever we are writing force into perpendicular distance we will call. So torque will produce rotational motion. Force will produce linear motion, otherwise it is going to stop, which is going to move according to Newton's second law. So if you are rotating any object, you require torque, not force. So if this is fixed here, door, you are applying force here. Now it is rotating, isn't it? So whenever it is rotating, you are not applying force, you are applying torque. Distance also should be playing main role. If you are applying force here, so where door is fixed, if you apply force there, if you apply infinite force also, there is no torque because distance is going to become 0. Next, if you compare with linear and rotational motion, so force we came to know, rate of change of momentum. According to Newton's second law, momentum is changing with respect to time. Same like that, torque tau is equal to, we will write dl by dt, rate of change of angular momentum, isn't it? Next, according to momentum definition, we wrote P is equal to mp. Now here L is equal to, in place of linear velocity we will write angular velocity. Now in place of mass, what we are going to write, that is only we will call moment of inertia. Here mass is a measure of inertia. Mass is a measure of inertia, which can move easily or not. Which can move easily or not can be decided by mass. Moment of inertia. So it is a measure of rotational inertia. Rotational inertia means object can move, means easily rotate or not, is decided by moment of inertia. How we will define this moment of inertia means, according to this one, if they derive the equation, you are going to get I. How it is going to be defined means product of mass and square of the distance of that mass particle. So if you want derivation for this, tau is equal to d by dt of, what is L bar here? L bar is nothing but R bar cross T bar. So whenever you are going to differentiate this, R bar cross dp bar by dt. So first we are making R bar constant. Next, P bar constant, dr bar by dt. Correct? So R bar d by dt of mv, isn't it? Otherwise, dB by dt we can write it as simply R bar cross F bar plus P bar cross dr bar by dt. So what is dr bar by dt means V bar. So P bar can be written as mv bar cross V bar. So V bar cross V bar can be written as 0. So this is going to be R bar cross F bar. dP by dt can be written as F bar. So tau bar is equal to R bar cross F bar. Next we will see angular momentum. So if R and P are perpendicular to each other, so this is R bar, this is momentum. Perpendicular to each other means we will write this one R into mv sin theta. That is nothing but sin 90. So we are going to get mvr. So whenever we are applying momentum, if it is rotating, so v can be written as r omega into so mr square omega. So mr square can be written as L is equal to I omega. So this one. L is equal to I omega. I can be written as m r square. These are the equations how we got from the definitions. Moment of momentum is nothing but angular momentum. Moment of force is nothing but torque. If you want units for this, distance units meters, momentum units kg meter per second. So kg meter square per second. Dimension formula we can write. So for this, what are the units if they asked? Force units, distance units, Newton meter. So it is like work dimension formula is going to be placing. Now how they are going to ask problems on this? They will give R bar, P bar, R bar, F bar. You have to apply cross multiplication. So we discussed in basics how to do cross multiplication. Now we will see one simple problem. Let's see. Position vector R bar is equal to 2i cap plus 3j cap plus k cap. So momentum P bar is going to be I cap plus 2j cap plus 3k cap. So what is the angular momentum? L bar. That is going to be R bar cross V bar. Same like this, in place of momentum they will give force. Any one if you do, remaining one is going to be similar. Now L bar is equal to R bar cross P bar. How we will do means I cap, J cap, K cap. So first we will write R 2, 3, 1. Next we will write P 1, 2, 3. So whenever we are doing, this is plus, minus, plus. So I cap, so this row, this column can be closed. 3 into 3 minus 9 minus 2. Minus J cap, so this row, this column can be closed. 2 into 3, 6 minus 1. Plus K cap, 2 into 2, this row, this column can be closed. 4 minus 3. So 9 minus 2, 7 I cap minus 6 minus 1, 5 j cap plus k cap. This is going to be L bar. If they ask a magnitude, what we can do? Root 7 square plus 5 square plus 1 square you are going to do. Same like this, if they ask force means we will do like this. Next term, similarities. So L we said I omega, linear motion, mass into velocity. Where we got moment of inertia, there we are going to get mass. Mass is a measure of inertia, moment of inertia is measure of rotational inertia. Okay, next term. Here force we will write in final equation generally MA. Here also we will write torque tau is equal to, in place of M what we can write? In place of A, alpha. Now again A can be written as in two ways. One is dV by dt. Here I is equal to d omega by dt. Next, another A can be written. F is equal to m. What is A means? V dv by dx. Acceleration is nothing but v dv by dx. Now here I is equal to, in place of v, omega. In place of omega, d omega by dx. Next, they will give angular momentum. L is equal to 2t plus 3t square. It is changing with respect to time. So what is the torque acting? What is the torque acting at a t equal to 1 second? What is torque formula? Tau is equal to dl by dt. So d by dt of 2t plus 3t square. How much you will get? So 2 plus 60. So at time 1 second, so 8 Newton meter. So like this also they will give. Next, they may give graph drawn between angular momentum and the time. So they may give like this. This is going to be 30 degrees. Then what is the torque acting on this? So torque means slope of angular momentum and time. That is going to be change in y-axis by change in x-axis. That is going to be tan 30. Tan 30 value. So 1 by root 3. Correct? So 30, 60, 1, 2. Correct? 1, 2 root 3, 1 by root 3. So however, whichever they are going to ask, you can see according to that we can calculate very easily, isn't it? This is about angular momentum and torque, how they may give questions.